In this video, we're going to quickly go through Just Hueth Schmitz model of Graham's 1981 paper, which presents the option price in a graphical framework. This is figure 12.14 in their text. The question that Graham is addressing here is, what does it mean? What's the value of a change from Z0 to Z1 under situations of risk to a firm? So we know that we're considering a firm that has two states of nature, a bad state and a good state. In the bad state, the welfare, the benefits to the firm are pi b. In the good state, the benefits to the firm are pi g. The question then is, if we move the firm from Z0 to Z1, what's the compensating variation or the compensating measure of welfare change that results? And Graham starts with thinking about it like this, and we present a locus of all the possible state contingent payoffs that would make the individual indifferent between the random situation with Z0 and the random situation with Z1. So consider one particular state contingent payouts, and that is when he pays a large amount in the bad state and pays nothing in the good state. So in this case, that value, that red dot right there, indicates a payment that would in such that in the bad state he pays a lot, in the good state he pays nothing. He'd be indifferent from that situation given that he's gotten Z1 to the situation in which he has Z0 but doesn't have to make a payment. Or we could take a lot away from the individual in the good state, nothing in the bad state, and again he'd be indifferent between those state contingent payoffs and the original situation in which he had Z0. Or we could take the same amount from the individual in both states, that is, take the money OP away from the individual before we even start, and he would still be indifferent between Z1 after that payment and Z0 without the payment. So we see that either that red point or that red point or the option price, all of those are options that would make the individual completely indifferent. They're all possible measures of the value of this change from Z0 to Z1. There's one other one that I'm going to look at to start out with that is particularly relevant. That is the set of payments that make the individual indifferent in both states. That is, we're going to call these points CB star and CG star. And what it means is that if we get the good state, then the individual is indifferent between Z0 and Z1 after that payment CB star, and in the good state, he is indifferent between Z0 and Z1 after the payment CG star. So now we have a fourth possible set of payments, state contingent payments, that we might want to consider. And of course, there's an infinite number of other alternatives that we might want to consider. Let's stick with this CB star, CG star, and think about what's the expected value of that. Well, the expected value of that is determined by the relative probabilities of getting in the bad state and the good state. And if we just use that line right there with the slope minus gamma over 1 minus gamma, where gamma is the probability of the good state, then the expected value of CI star is simply the point on that line, on that straight line that intersects the 45-degree line. So the expected value of CI star is the red dot right down there in the middle. Now we can compare that to the option price, which says the option price, the expected value of the option price is clearly the option price because it's a payment that's made in both the good state and the bad state, and the option price is better than the expected value of CI star. So the option price is larger, indicating that the move from Z0 to Z1 has a higher expected value than the expected value of CI star. And the difference between CI star and the option price is what they call the option value in this model. Now there's one other possible point that's worth considering here, and that is F. F is the point on the PP frontier that has the slope equal to minus gamma over 1 minus gamma. That is the point on the frontier with the highest expected value. So if we are able to make state contingent redistributions, that is, if there's an insurance market that will pay off in actuarially fair insurance payments that can bring the person to the point F in which they receive make a little bit more of a payment in the good state and a little bit less of a payment in the bad state, but every single year they make the payment. The insurance company has on average the payment F bar, then that point F bar is actually above the option price. It's an even higher estimate of the value of this change from Z0 to Z1. So if it's possible to make actuarially fair redistributions and we want to take that into account, then you can use F bar as your welfare measure. If you don't want to allow for that, if you want to assume that the ex ante, what's the most that the individual would be willing to pay in both states, that is, prior to the states being revealed, such that the individual is indifferent between Z0 and Z1, then we're talking about the option price. That's the full model, or the full figure as shown in figure in the book. I think it's a little bit easier if we work it through step by step as we've done here.